We're gonna get started in just a second. Just let me know if you can hear me okay. Okay, nice. Okay, so welcome to the stream. As you probably saw in the announcement, we're looking at scaling concerns in the stream. But before we begin, as usual, I gotta do a couple channel update and announcement type things. And then in the meantime, if you have any questions that you'd like me to answer live in the stream, you can ask them in the chat there. Now, there is new prefixes you can use to ensure that I get your questions. You can put Q colon question, or question colon, and that will push them over to Discord, and then they'll be curated over there, and I'll be able to see them. Sometimes the chat gets kind of hectic, so I can't always actually read everything in the chat. I do my best to look over a chat every now and again, but sometimes I miss it. So the best way to get me your questions is to use one of those 4 prefixes. So feel free to ask those now after the channel update announcements, which is not going to take that long because I don't have a whole lot of stuff. Plus, we got a lot to cover here on this this kind of main content for scaling matters. So please ask your questions now if you have any. So for the channel update and announcement, we do still have stickers for sale. They are nice 2-inch by 2-inch Engineer Man E stickers, and if you're interested in picking up some of those, you can go to emkc.org/stickers. They're being sold at cost right now, as they were gifted to the channel, about 300 of them. I've sold probably, well, I haven't sold them all. I've given a lot away as well. I probably only have like 80 left, so now is the time to put your orders in. Also, if you are an EMKC Master, EMKC Hero, a Discord Hero, a supporter, Nitro Booster, or you've done anything to support the channel at any point in time, you are entitled to 2 free stickers. I'll ship them anywhere in the world. So if you would like a coupon for that, just DM me or one of my staff, and they'll give you a coupon to put into that site, which will make them free. The last thing is fan project review. We are coming up to the end of the Season 2 Engineer Man live streams. We only have, after this one, we'll have 1 more, and then we'll have the fan project review. So the time to get your projects in for fan project review is, we're getting close. The deadline is about 1 month from now. I think it's December 26th or 27th, somewhere around there. So you'll want to get me your project in before that. I've received 1, 2, 3, 4, 5, 6, 7 submissions so far for projects. So as of right now, we'll be doing 7 of them, but I still have room for probably another 4 at least. Otherwise, you're gonna have to see my projects, and you don't want that. So if you have a cool project that you want to get shown on this live stream, make sure you send it over to me. The email is projectreview@engineerman.org, and I'll put that in the chat. I'll also put it in the description. If you are watching this from a recording, then you can get it from the description, but it's projectreview@engineerman.org. Send it over to me. The only requirement is that it be, the source has to be provided. I won't run a random executable. I won't just run a binary. I need to actually see the code and all that. So if your project is, kind of cool, unique, or it's something you're real proud of that you think other people would, think it's kind of cool, definitely send that over to me. I would love to show it in the final live stream of the season. So send those over. Okay, so far no questions. Let me look here. Okay, no questions so far. That's perfectly okay. We could just jump into the content, and then I'll take questions kind of as we go. So if you see any questions about any content that we're going to look at here, I will just answer those as we go. No problem at all. Okay. So the reason I chose this topic as one I wanted to do during a live stream is because it's really a skill set that you have to understand, because scaling is not just, scaling is not just taking your app from, 10 active users to a billion active users. It's also just doubling the number of users and then assuming that when you double the number of users, you get double the demand. And then once you get double the demand, there become some challenges that come with that. And there are some people that they'll never have to worry about this. In fact, a lot of businesses will, they'll have a site online and it'll do just fine for the life of the business. I've done consulting for multi-million-dollar companies that are able to run all their stuff on just one server. And they're able to do this because different businesses have varying degrees of dependence on their actual website. Not everybody has a cloud application that gets thousands of hits a day. For instance, there might be businesses where they just sell their product one time on their site, and that's just kind of it. And then once the person has the product, they have no real need to ever, go back. The same thing is true for subscriptions. If the subscription is purchased and there's no, you don't actually use the site to do the thing with that subscription, perhaps it's something you get in the physical world, like, movie theater discounts or whatever, then in that case, people are just returning to your site once a year to renew. So you could have 200,000 members doing $10 million a year, and if nobody needs to use your site, then you don't have any scaling issues. One simple DigitalOcean server can, oh, stickers. Thanks for being you. No, thanks for being you, French Fruits. French Fruits is a longtime supporter. Probably has been to every stream, and thanks so much for that, for the 20. I like the little sticker. That's something new. I didn't know you could do that. That's pretty neat. But thanks for being you is actually the word, and supporting the channel and coming to the streams, hanging out in Discord and sharing your knowledge. So thanks for that. So, some people get away with just one server. It's perfectly fine, and that's just what it is. But there are going to be people where they are going to have to cope with additional demand. And when they cope with additional demand, it brings about a lot of new challenges. And that's kind of what we're talking about today, is when you double the users, you double the demand. That's the assumption that we're making. And technically, that's almost always true, because if you consider, even in the case of a business that just sells a single product, and that's really it, if you double the users, you do actually double the demand. It's just you're doubling it from 0.2 of one, or you're doubling it from 1% CPU to 2% CPU. So it's not a real big deal. The problem is when your users are already using, say, 50% of your machine, and you double it, and now it takes 100% of the machine, and now you got big problems. So primarily what we're looking at today is those kind of things, is what happens when you scale beyond that first server, because that's where the real problems will come. Okay. So when we're talking about scale, we're talking about coping with a number of things. We're talking about coping with the additional computational needs. So that's going to be the actual servicing of a request that comes in. Coping with the additional storage needs. That's going to be, think like Facebook and Instagram. People are constantly posting pictures there. So they are constantly coping with an ever increasing size of storage for photos. Possibly, I'm sure they're well into the petabytes, of storage. And then I'm sure eventually, one day when bandwidth continues to increase and we continue to upload bigger and bigger and bigger things, I'm sure we'll be on our way to, 1 exabyte of stuff. And this is just, a mind-boggling amount of data. A lot of us will only kind of see gigabytes, possibly terabytes worth of data, maybe, but once you get to their scale, you're dealing with massive amounts of data. Camilo Pereira, thanks you for the 5. As a software engineer, I appreciate the work you do and the quality of your content. Thanks for your contribution to the community. You're very welcome. It's something I really enjoy doing. I love doing the streams. I love doing the videos. It's very important to me because I like to communicate knowledge and set people up for success. And that's kind of what we're doing in the Engineer Man community. Is we're in some cases changing lives, and it's fantastic, to watch people grow both personally and professionally, and build a real school tool set and improve on that tool set, to solve the problems of tomorrow, and just being a force for good instead of a force for bad. So yeah, I appreciate your support. It means a lot to me. It means a lot to the community. And welcome to the stream. I don't recognize your name, so possibly you've been on other streams, but thank you for being here for this one. It should be some good content. So beyond computational and storage, you also have a problem with now backups. Because if you have a small site, if you have a small amount of data, it's pretty easy to just run a backup, on your entire server or on just your database or something like that. It's easy to just say, boop, one click, and it backs up for like 5 minutes and it's done. But the problem is when you're trying to deal with terabytes, hundreds of terabytes worth of data, backups become a little more complicated. You can't just say, okay, well, once a day, I'm just going to duplicate all this data, because you'll eventually get to the point where it takes a full day to duplicate that data. And then what do you do then? What do you do when you you reach the end of the window to duplicate the data only to have it start duplicating again? So that's not ideal. So you got to find a way to cope with that, and we'll talk about how to do that. So there should be some specific goals when you're operating at scale, and that's you want to maintain the same fast response time to the user that they had when they were the only user on your platform. It doesn't matter if you have one user or 100 million users. They should all get the same experience. They should all get the same fast response time, and they shouldn't realize that they're one of 10 million users, and they shouldn't care about the infrastructure on the back end. You should be handling that and delivering them a good experience. So fast response time is very important, because when you max out your server, of course, it's going to start, servers can only do so much. That's the nature of the thing. They can only service so many requests, and they can only handle so much demand. And then you as the engineer have to do something, to mitigate all that. So you also want to maintain a high degree of reliability and availability. And this is the idea of, your services need to stay up. It's sometimes okay if the service is slightly degraded, as long as it's still up, but it's very bad if your service is just down. In some cases, it can cost tens of thousands, hundreds of thousands. I'm sure when you're at Google scale, if something major goes down, it's costing millions. So you want this high reliability, high availability. And then you want to maintain like a high degree of durability of information, because nothing is going to make your user dislike your service more than their data not being durable. If they can't trust that their data is there to stay, then they're not going to use your service. So, and as you scale up, it's important that you have a way to ensure that you don't just have one copy of user data. And then if something goes wrong, whether it's hardware failure or something like that, then you got to have a way to get that data back online for that user. Otherwise, it's just going to erode, their confidence in your product. You also need to, another goal is maintaining failover infrastructure. And this is to ensure that if you have a problem with like an application server, and this is not necessarily storage, we're not speaking about like photos and whatnot, we're speaking about the actual backend services that keep your site online and delivering stuff to your user. So like if you have, say, actually, the cool thing about failover is as you scale, failover gets easier. And that's because you end up throwing more servers at the problem. And it's like, if you have 10,000 servers, do you really care if one dies? No, of course not. It just means you have 99,999 servers now. But if you are operating on just a 1 or 2 server kind of setup, and both of them go down, maybe because they're on the same region and your vendor's having problems, then you need a way to cut over to separate infrastructure. That way the user is not interrupted. And then another goal is only having to engineer solutions once. And I throw this in here because you don't want to like go back and do this again. You know, if you're going to go through the effort and the time. Oh, Thanos, thanks a lot for the 10. I appreciate that. Another long-term user. I've seen you a lot here. Welcome back to the stream. I know. I think I've also seen you in some YouTube comments. I think we've had some back and forth. So thanks for attending the stream. It's good to have you. So I bring up engineering solutions only once because you don't want to go back and redo this again. If you spent the time to engineer a really good solution, then you might as well just do it once. And the good thing is you don't have to do this up front. Like, you don't have to make a brand new app that has no users and go crazy with the over engineering, you know, of like the scaled form of what you're doing. You know, it's fine to use one server to start. A lot of people will, and it should serve you until your app grows. But the other thing it lets you do is it lets you gauge where the pain points are and what you need to focus on primarily in scaling. You know, obviously some applications are not going to have a storage problem, but they're going to have a computation problem. Others, they're not going to have a computation problem, they're going to have a storage problem. So you kind of get a lead time to make sure you understand your problems first before you engineer a solution. Because the worst thing is wasting a lot of time, possibly money. You know, if you're consulting with people or hiring other people to do this for you, the worst thing is wasting all that on something that you will then have to redo down the road just because your initial solution didn't work. Now, of course, sometimes that's avoidable. Sometimes that's unavoidable. You know, it's not... The times where it's unavoidable is when maybe you get the customer need wrong, and so you design your infrastructure wrong, but that's just adapting to new business needs. You know, it's one thing to like mess up a clear-cut thing, and it's another thing to get that thing right, but get the need wrong, then have to go back and do it again. And that's just what it is. But if that's happening, it probably means your load is low anyways, because your actual offering is not ideal. Let me see if there's any questions here. Zach asked, when building a web application, what are things that I should be thinking about when building it before scaling is even thought on the radar, i.e. what should I be doing to make it easier to scale? Yes, so that's actually a fantastic question. And it's fantastic because there's some small things that you can do up front to kind of mitigate a lot of these problems right off the bat. Now, the first thing is like for storage, we're going to talk a lot later about, you know, managed object store, and there's no reason not to use that because it's just as easy to write to this kind of, we'll talk about this later, but you know, it's just as easy to write to a network store that's managed elsewhere as it is to write to a disk, except with the network store, it's available everywhere. With your disk, it's only available locally. So that's one thing. The second thing is, and this is a lot of people that get this wrong, is if you're doing sessions, don't use files. You know, right off the bat, that's going to cause you problems because the minute you duplicate and go to two servers, server 2 can't see the files of server 1. Therefore, every time the user hits refresh, they're seeing a different session. And that's, of course, not ideal because on one refresh, they'll appear logged in. On a second refresh, they'll appear logged out. And that's not good. So, you know, don't use file sessions, use object store, and those are probably the two major things. And then put your application behind like a reverse proxy. That will also make it easier. Those are some small things that you can do before you go forth and, you know, scale it out of control. Answer this question. I don't know how to answer it though. Is it worth rushing to pass Cisco certs before they change in February? That's actually, Zach might be able to answer that. I don't know that answer. I don't know a ton about Cisco certs, so I can't help you there, unfortunately. Sorry about that. Okay, so next thing that's worth looking at is, well, actually, we kind of covered a lot of this. You know, it's this idea of, do you need it? You know, and I put this in the stream because it's important that you don't rush into this. You know, don't rush into wasting time on scale when scaling might not even be a thing. You know, because a lot of businesses don't make it. So if it's a new business and you're just trying to get stuff going, the last thing in your mind should be, how do I support my future 100 million users? You want to support your current 50 users. That's what you want to support. And then as you grow, you can start worrying about this later. So it's important that you kind of do it when you need. You also have to look at, does your demand scale with users? And typically the answer will be yes. Sometimes it's not. It just depends on, like if you have a varying degree of subscriptions, for instance, maybe you have a 1 year, 2 year, 5 year, or whatever, an increase in users may not actually equate to an increase in demand, because it all depends on what subscription they get. Obviously, if you have 100,000 users get a 5 year and you have 5 users get a 1 year, then you don't have to worry about any additional load for 5 additional years. But if they all get the 1 year, then they come back every year, and you add that on top of the additional demand that you have 1 year from now. So you got to kind of look at, does demand scale with users? And if you look at businesses like, like Facebook, for instance, or Instagram or Twitter or whatever, those are services where a doubling in users probably results in a doubling in demand. And that's just because on average, people do a certain amount of stuff on Twitter, and they can just expect that everything will just double. So then it's, how important is your application to your business? We talked about that a little bit. This is that idea that not everybody needs a cloud. Not everybody needs a cloud presence. Not everybody needs a website that people use a lot. Sometimes it's just a static front end with a place to buy something or something like that. So you have to assess kind of how important that is. So at this point in the stream, we're getting into the actual like bits and pieces of the things that you'll need to scale. And then for every kind of scaling concern here, we're going to talk about challenges associated with that concern, and then options to alleviate the problems. And definitely ask any questions, because some of this is going to be kind of confusing, especially if this is kind of new to you, but I'll try to make it make sense as best I can. But ask questions if something is unclear. Always happy to answer those. Ivan asked, your opinion on GraphQL, and can we expect a video on it in the future? Probably not. I don't know. Maybe. That might be... I'm not sure yet. I'll have to get back to you on that. Do you have any advice to maintain DNS entries at scale? We have plus 10K instances. DNS entries for the applications are handled manually, so it's common to have entries pointing to the wrong... Oh, it kind of got cut off. I don't see the rest of that question. Maintaining DNS entries at scale. So if you can... There's kind of two ways to do this. The first is you can use a managed service, such as like Google DNS, something like that. The other option is, of course, you can run your own DNS servers. That is possible. And then there is a way to basically load balance to various name servers. That's another way you can do it. But 10K instances, I guess maybe just give me some clarification in the chat. Is that 10K instances of I guess just clarify what that is. I'll come back to that question. So the first concern is that we're going to look at is network scaling, and this is just the process of making connections reach a server. This isn't even doing the actual processing of that request. It's just getting it from like a phone to the server, or a computer to the server, or a server to the server. So the challenges of network scaling is that once you introduce one additional server, it means that you have to scale your network, because like when you create a cloud host, you get an IP, and you can point to that IP with using a domain name. You can add an A record and point to that IP, and then all is well. It's fine. It's a one-to-one analog. Domain equals one IP equals one server, all is well. It's super easy. There's no drama. The second you introduce a second server is now you have problems because you can't have two IPs. You can't do that because that won't work because people are only going to be accessing one domain name, which will point to one IP. So you'll need to insert something in between your DNS and your servers, and that's going to be what we call a load balancer. And we're going to talk more about what those are here in a second. So another challenge about network scaling is sometimes it is not cheap, especially if you are using hardware. Now we'll talk more about hardware load balancing in a little bit, but if you buy like a hardware load balancer that's designed to be rack mounted in a data center, it's going to be pricey. But at the same time, it's going to be the best performance and the best feature set you can get. So here again, can your business afford it? You got to make that determination. Another challenge with network scaling is a lot of the times, and this is part of the question that Zach asked, is if people don't develop their applications to be stateless kind of from the get-go, then they already have an issue when they add a second server. Because the implication is if you add a second server, you've also added a duplicate of your application. And once you do that, then you got to look at, does your application, can your application run independently, or does it depend on something on that server? Because if it depends on something on that server, then a connection to server 2 can't depend on something from server 1. That won't work. So when you go to greater than one server, it requires you to basically see your application server as clonable without any change. And this is something that people make this mistake all the time because they don't, a lot of people just don't think they'll ever need two servers, and a lot of the times they're right. But this is a mistake that's made all the time because it causes people to have to go back and change how their application works to cope with being on what is now two servers. So another challenge with network scaling is socket connections. The thing about socket connections is when you have one server, a socket connection goes to that server. And then if you're like publishing messages on these sockets, it's fine if it's all on one server because all the connections are right there. But what happens when, client 1 is hooked up to server A and client 2 is hooked up to server B, and client 1 publishes a message, needs to cross, the chasm here between servers and then get back down to client 2. How does that work? And this is another challenge with network scaling, and that's just two servers. The good thing is solving the problem for two servers is the same as solving the problem for 10,000 servers. That's the good thing. It's just going from 1 to 2 is hard. So for network scaling, you have several options. The most common of which is just we'll just call it the load balancer. And there's a lot of solutions for this. The most common is a software load balancer. This is something like Nginx load balancing or HA proxy, something like that. And the whole purpose of these things is to take one incoming connection and determine what server it should go to. And you could put, the load balancer, the expectation for a load balancer is that it's mostly just handling traffic. It's not doing any computation. So it's like one load balancer can service way more servers. It's not like one load balancer is only good for 3, because if a server is doing a lot of computation, the load balancer is just sitting there idle. Its job has 0 to do with actually servicing the request of the user. It's only about routing the request to a server that is able to handle it. And then there's also, a lot of newer load balancers, they support what's called DSR, which is direct server return. And this is a thing that basically allows you to make a request to a server through a load balancer, but it allows that server to respond directly to the client. And this is actually a huge deal because traditional load balancers, the network, it goes through the load balancer to a server, and then it comes back out of that server back through the load balancer. And this is a problem because if you have a network heavy application, then you're going to saturate that load balancer. But if you have direct server return running, you're able to just send it right back from the server to the client, and the load balancer doesn't have to take all this extra traffic going through it. So if you have technology that uses direct server return, of course, that's the best way. But if you don't, then you don't. So if you can afford it, hardware load balancing is also a great option. The problem with software load balancing is you are at the mercy of the load balancing vendor. And sometimes that's a problem. Maybe you don't want to be dependent on that. Also, of course, it's going to cost a lot. Or I'm sorry, that's for hardware. For software, it's going to be free, but free has its problems as well. So if you can afford it, hardware load balancing is a good option. But the other implication of hardware load balancing is that it's hardware. So if you're running on cloud infrastructure and you're not in a data center or something like that, then you can't use hardware load balancing anyways. Unless, of course, your cloud vendor offers some feature called a hardware load balancer, in which case you can definitely use it. I'm seeing a couple questions. Let me make sure there's nothing here. Angel, what is well, let me know what a WAF is. I'm not familiar with that acronym. Sorry about that. Just let me know that, and I'll look at that here in a second. So once you're beyond hardware load balancing, then there's another option that's just manage load balancing. A lot of cloud vendors, they offer kind of load balancing as a service, and they just say, hey, point your DNS to this IP, and then we will make sure the traffic gets to where it needs to go. The good thing about managed load balancing is oftentimes they are infinitely scalable, meaning that you can throw 1 request a second, or you can throw 50,000 requests a second, and it will still get to where it needs to be. But at the same time, it's sometimes pricey. Usually with managed load balancing, not only are you paying monthly for that balancer, you're also paying for the load balanced traffic that runs through it. So again, it's all a cost thing, but if you can afford it, that's actually a really good option, especially if you're running on real good infrastructure, something like Google or AWS. So once you get to the point where both software load balancing, hardware load balancing, and managed load balancing is just too much, you now have this option to do what's called round robin DNS. And a lot of people don't realize that you can put multiple IPs on the same host on a DNS server, and they will just go to each one. And the cool thing about having this is, in the same way a load balancer allows you to add a second server, round robin DNS in some cases allows you to add a second data center. You can have like one IP point to one place, one IP point to the other, and then now you have stuff that's routing to specific data centers. And this is a very powerful thing to do, and it's something that a lot of people don't realize even happens. Like and I'll give you a quick example. I'm gonna open a terminal real quick here. So if I just do NSLookup like Facebook, of course I'm only getting one IP, but hold on a second. Okay, like here's an example. So when I do NSLookup Google, I'm getting all these IPs. And the reason I'm getting it all is because this is like configured in a round robin kind of way, is that I'm gonna get one of these IPs if I go to google.com. I don't know why Facebook's not. It's possible that this IP then splits to various other things. I don't know the specifics on certain things, but that's why that's like that. That's why google.com resolves to 6 IPs, as an example. How to decide better load balancer, ELB versus ALB? I don't know why I don't understand these acronyms. ELB, is that elastic load balancing versus ALB is what? Go ahead and let me know what the yeah, IPv6. Well, let me know what ALB is. I'm not familiar with that. So, and then finally, if round robin DNS and managed load balancing and you have big data centers, if that's still not solving your scalability concerns, because maybe you're a global company like Facebook, for instance, now you can have geographically specific round robin DNS. And this is this idea that if I'm in Western United States, I get 6 IPs to go to for Google. If I'm on Eastern United States, I get 6 different ones. If I'm in Europe, I get 6 different ones again. So now we're talking about actually load balancing based on geographics to various data centers, which then load balance to different servers. Like load balancing it's all about layering. There's always a bunch of different layers, and traffic will go through several layers before it even hits something like an Nginx server. We're talking about purely the actual bits flying down the wire here. We're not even talking about what happens when it actually reaches your application. So and I have these listed as options, but it's not like you pick one or the other. You don't pick like software or hardware. It's possible that you have hardware load balancers in front of software load balancers. So you got to just choose the ones that make the most sense, but know you do have options, and you could scale these pretty well. The people that ask questions, please make sure you put your ALB application. Okay. ELB versus ALB. So I would say, if I'm understanding that correctly, Elastic Load Balancer is more like the managed, and ALB is more like the software. So I think it just depends on, I think if you can use Elastic Load Balancing, that's probably the best bet, because you don't have to worry about kind of adding additional software load balancers yourself. So I would pick ELB as the option, and lots of services have that. I'm not sure if Elastic Load Balancing, that might be an AWS term. Maybe Google calls it by another word. I primarily do stuff on Google. I don't do a whole lot of AWS. If it helps, it's Nginx, EC2, and routes to proxies. Okay. Yeah. So yeah, speaking about ELBs, that's going to be, the equivalent on Google is Google Cloud Balancing, and then various services will have some sort of balancing that they can do kind of at the, the vendor level, and that's the best option if you're able to do it. But keep in mind that managed load balancing only works if you're in the cloud. So if you're running your own, if you co-locate, for instance, like if you put your own racks in a data center and you run all your own servers on your own, then you don't really have access to that. You then have to build your own servers specifically for that purpose. Yeah, Fox, he said, working on a long, ongoing custom e-commerce platform where all former devs have made horrible scaling decisions. How to explain to the project manager that we need to stop adding bloat and fix it. The best way I've found to do that is to basically show them the 2 paths that they can take. There's 2 paths. There's one, the first path is accumulate lots of technical debt. Actually, make it seem like it's going to cost money. If you could show that the mistakes are going to cost money in the future, then you're much more likely to get buy-off on fixing them now when it's cheap. So every now and again, there's 2 types of scaling decisions. You did mention bloat. Typically, bloat is just, messed up software, but scaling decisions could be a hardware issue too. So I guess it just depends on what the exact problem is. Try to frame it in terms of dollars. Say like, we can only go so long before this is a real problem. So we need to think about addressing this soon, at least in some small pieces, and just take a step back and make sure that works before we proceed. But again, I don't know your business. If some companies don't care, some companies are happy to just keep developing new features and don't care about scale, give their users a bad experience. They don't really care about that. And that's just what it is. Not everybody is, really user conscious. Officially JK, thanks for the $2. I appreciate that. Thanks for the heart. Thank you for being on the stream. I've never seen your name before, so if this is your first stream, welcome. Hope to see you on additional ones. Hi, Chase. So next thing we're going to talk about is computation. Computation is another major kind of scaling thing that you got to do, and this is the actual servicing the request the user made. So we've assumed now that we have proper network infrastructure to get the requests to the server, and now the challenge is actually serving that request in a reasonable period of time. So the challenge, of course, is that one server can't handle everything forever. We've talked about that. As you scale up, you require additional computational power. Another challenge is that your application, again, needs to be stateless. If you're adding servers to add capacity, then your applications cannot depend on things that are on that server. Your application really should be thought of as a thing you can snapshot and just duplicate to other places. There really shouldn't be this idea of like, oh, well, I'm making system specific changes over here, but not over here. You should be doing it en masse, and everything should be changed at the same time. And I talked about this, Zach asked this question, once you go greater than one server, you can no longer use file sessions. And I don't know if it's still the case, but PHP applications used to use file sessions by default. And of course, this is a huge problem because it means that a lot of applications out there can't scale past one server because they still use file sessions. And I don't know if this is still the case in PHP 7, but if it is, that's a major problem. And a lot of people will deal with this if they have to scale their information or their infrastructure past one server. So you have a couple options to solving the computational needs of your application, and we usually call this scaling up and scaling out. So the first option is to scale up. And you typically want to do this first because it's easier. So when we talk about scaling up, what we're talking about is we're adding capacity to the server itself. So we're going from like 4 to 8 cores, or 8 to 16 cores, 16 to 32 cores, or whatever it is. And then we're adding RAM, going up to 32 gig, 64 gig, 192 gig, 384 gig, whatever it is. I mean, there's cloud hosts where you can get massive amounts of RAM. I think I've seen one where you can get 512 gigabytes of RAM, and you can add like 96 cores to it or something crazy. So, you can do that, and sometimes scaling up is a good option because usually when you double the size of the server, it only doubles the cost. So you can either have 2 servers of the same size or one server that's the same size as the 2 combined. But at some point you can't, at some point you get diminishing returns. And that's because, can your application even utilize 96 cores? Will it utilize 96 cores? If the answer is no, then scaling up might not be a good idea. You may need to scale out. So the second thing is scaling out, and that's basically taking these already scaled up servers and just duplicating them. And in doing so, you're able to just add capacity that way. And if your infrastructure is set up appropriately, you should be able to just say, all right, well, I got 3 servers. I'll clone number 3 to make a 4th, drop that IP into the load balancer, and you're done. You just added capacity, really quickly. So that's the primary way to do that. And then the third option is you can offload some processing to this idea of serverless infrastructure, serverless architecture. And this is this idea that in the cloud there are cloud functions that can do things kind of on demand. And of course it does involve a server. It just doesn't involve a server that's running all the time. And it's not something you have to manage. You're building these kind of discrete routines that can run on demand with just the cores and RAM they need to function, and then you can use that to kind of offload some of the processing on your normal machines. And this is the thing that all big companies use. All big companies will scale up and scale out, and then they'll go one step further though. They'll like duplicate data centers. Once they have their infrastructure good to go, they can just obviously you can't copy and paste a building, but if you could, that's what they do. They copy paste a building, put it somewhere else, and then they'd add that IP for the data center into DNS round robin, and then away they go. And in that way they can, because remember, doubling, if we go from 100 users to 200 users, and we double our infrastructure, it's the same as Facebook going from 300 million to 600 million. They double their infrastructure. You know, the process is the exact same. It's just what scale are we doing it at? So another scalability concern is storage, and this could be kind of a problem, you know, because storage really ranges. You got storage of user data, you got storage of user content, you got storage of database type things or things your application needs. And you could think that there are applications that have huge amounts of storage need. You know, like YouTube, for instance, people are uploading gigabytes, you know, per person per week in some cases, and I'm sure they're taking in. I mean, YouTube's got to be ingesting terabytes a day, I suspect, and that's just a massive storage need. Plus, I don't know if you know how they have it in different, you know, sizes. I don't know if they are like dynamically, you know, reducing the size, or if they store several copies of the same video at different sizes. But if they are, that's just insane amounts of data, and just how do you reason with that? So one of the challenges with storage is that what happens when you are serving a globally diverse audience. You know, if you're based in America and you're serving customers in Europe, you have to deal with this problem that they are going to have to download that data over a wire that's going under the ocean. You know, and while the ping is pretty good, you know, for being a wire that goes under the ocean, it's still not ideal. That's a long distance to cover, you know, several thousand miles. So if you really want to give your global users a good experience, you have to get a copy of your data closer to them. And this is where I didn't explicitly mention this, but this is kind of where content delivery networks kind of come into play. You know, these are responsible for letting you upload data to one spot, which they then replicate to various spots, and they use those geographically specific DNS, you know, mechanisms that allow people to request, you know, people in Europe request information from servers that are already in Europe, you know, versus having to go all the way to America for that. Let's check questions. Okay. Yeah, web application firewall. Okay. For load balancers, do you configure web application firewall with the load balancer, or is it separate from the load balancer? So it's both. It's both. You can, if you're using like a managed firewall, something on Google or Amazon, you should be able to configure certain ports to just say, you know, don't. You're getting an implied firewall by only forwarding a certain number of ports. You know, if you say that this load balancer should only forward port 80 and 443, then you're kind of implicitly putting a firewall there that doesn't allow any traffic besides those ports to flow through the actual load balancer. So, but if you forward everything through the load balancer, then you can use a traditional firewall that exists at one layer beyond that firewall. So I'm sorry, beyond the load balancer. So once things get through the load balancer, they can hit the firewall, that can filter out things. And then if they are allowed, they can flow through to the proper servers. So I think it just depends on how you're configuring it. But in general, you will just do it that way. You'll just prevent, I mean, typically, at least for web applications, you only really want 80 and 443 to come through anyways. So that's how you would do that. And then generally, if you have other services that run, or you need to like SSH in, generally what you do is you would SSH into a machine that then has access to the rest of your infrastructure. That way you just have basically one inlet machine, or a bastion server, or, you know, there's various terms for it, but that's how you'd often accomplish that. Thank you for that question. That's a good question though. So for storage of user data and whatnot, you know, the second challenge is that what happens when your storage exceeds that of one hard drive. This is a problem because what do? And the answer is you have to distribute this across drives, and this can be done either with using like a RAID setup whereby you are making a number of drives appear as one logical drive, even though it's multiple physical drives. You can do that, but there's probably a time where you even fill that up. You know, what happens when you have one logical drive that's massive, but you've filled that up? You know, the answer is now you have to distribute the data across even logical drives. And once you do that, that's kind of your infinitely scalable option. Now, I keep using this this phrase infinitely scalable because you want to think of it in the terms of I should be able to do, you know, I should be able to apply X solution towards problem Y every single time for the remainder of the application's life. You know, that's an ideal scalable solution, is that you're not like, you know, clock's ticking, 3 years from now, you know, we're in big trouble. You know, you want to pick solutions where you can infinitely scale something, assume that the entire global population is using your application all at once. You know, it's, if you can scale to that point, then that's the most that could ever happen. So you have a couple options for storage. You can increase drive capacity. Like I said, you can use RAID. You can make things appear as one logical drive. That's a great option, but only if you have access to that kind of stuff. Again, if you're in the cloud, if you're in the cloud, things are happening within the cloud host that you might not be aware of. You know, like when you attach storage to a virtual machine, you know, it's not some Google employee like taking a 40 gig hard drive and running to your machine and plugging it in real quick. You know, they're not doing that. Often what happens is they run this massively huge network attached storage, and then they just carve out a little bit and they just plop it on there and make it appear like a physical drive. But a lot of attached storage that you get, you know, with like block storage and volumes, you know, with cloud hosts, you're really just getting just a piece of network attached storage that they're just tacking on there. So that's that. And then there's also, you know, managed storage you can get. And this is back to Zach's question about what I can do. You know, they have these things called object storage. And essentially all it is it's a place to store X data at Y path. So I can store a picture of Chase at something called, you know, pictures/best pictures/chase.jpg. And then I can access that as if it's an object, but I can also treat these things as folders, even though they're really not. It's really just bulk object storage that's organized by paths that you can access by paths, or you can access by, you know, you can treat them like folders. That's one of the cool things about it. And these are, again, infinitely scalable. You know, they say that there essentially is no drive limit. The benefit of the managed storage stuff as well is you're only going to have to pay for what you use, and that's kind of nice. You know, whereas if you do block storage or you run your own machines, whether you have 10 gigabytes of data or 1 terabyte worth of data, you're still paying for the stuff. And storage is cheap. We're talking like 2 cents a gig. You know, it's really no big deal today. Hard drives are so cheap that is what it is. So another matter is databases, and again, you're noticing that we're picking key points of applications. Like every application that runs on the web uses these key things. They use network, they use computation, they use storage for user data, they use databases, and you'll see that we get down here, you know, they take backups, they need failover, and these are all things that common applications are going to do in the course of their lifetime. So I've broken databases down to 2 things specifically. The actual database itself, and then the design choice for the database. So when we speak about databases, we're talking about the maintenance of schema and schemaless databases. And you know, the challenges for a database is the same as the challenges for a server. One database server cannot service all the load forever. And then this is going to cause you to have to use what's called clustering. And this is where you take several databases, put them together, they talk to one another, and they appear as if they are one logical database to your application, but when in reality, they're being written to various nodes in the database, which then replicate their information to each other, and then you get the ability to read from any of the databases. So by clustering, say, 5 databases, you essentially 5 times your read capacity to get data out of there. And a lot of the times, we're going to talk about read writes a little bit later, but a lot of the times applications are read heavy, and therefore clustering databases is a good option for scaling that up kind of easily. Because if you're at 100%, if your reads, if you get 99 reads to every 1 write, then just adding a second database server should increase capacity by 2, and that makes it easy. But one of the challenges is cluster configuration. It's not straightforward. There's some configuration you got to do. There's some proper tuning you got to do. There's some challenges there. So when you have to cluster databases, it does require some specific knowledge. The second thing is if you're dealing with sharding, and sharding is this idea that, say you have one database table. Sharding is this idea that like records 1 through 10 million reside on one server, 10 million and 1 to 20 million reside on another server, and so on. So sharding is this idea of partitioning data within one logical table across machines. And this is usually used when you have massive tables with massive amounts of data that you can't just fit on one machine. You have to push it across multiple machines. But here again, with databases, they have managed solutions. You can get those at any cloud host, and again, they offer where you just say, I want my database to be 8 gig or 16 gig, and then the storage layer of the database can be scaled infinitely in the same way that storage can be scaled infinitely. So the other part, I'm trying to speed up here because we only got 3 minutes. So, but we still got some stuff to cover. This stream might go a little long. I apologize. So the second thing is actual design. You want to choose the right tool for the use case. And again, this is the actual, you got to get it right. You have to account for the expected read-write ratio. If you have a high rate of reads to writes, then there's specific tools that work really well for this. Such as like, MySQL, MyISAM, engine is great for high rates of reads. Whereas like Cassandra is great for a high rate of writes. So you want to pick the right thing for the job. If you have a high rate of reads or you have a high rate of writes, it's important that you don't choose a suboptimal product in the near term, because you're just going to add yourself some pain in the long term. And I'll tell you one thing's for sure. You really don't want to deal with having to migrate massive amounts of data when your application is already very popular and being used by a lot of people. You don't want to do that, because you're going to incur downtime and people are going to get upset. But you have options. You got relational databases that are ACID compliant, meaning they can do transactions properly and not be subject to corrupted data in terms of like power loss or whatnot. So ACID was atomicity, consistency, isolation, durability. That's something that's specific to things like MySQL, Postgres, whatnot. But you also have these schemaless. Oh, I did shared, but I meant sharded. Schemaless, sharded, highly scalable databases is like your MongoDB type of thing, where you can push data across nodes, but you're not getting that ACID compliance. You're not getting joins. You're not getting the rigid table structures, and sometimes that's not ideal. Some guy in Sandy, thanks for the 20. Thanks, EM. Great info as always. I appreciate the support, and welcome back to the stream. Of course, I've seen you several times. I don't know if you're in Discord. I know I wanted to mention we have a supporters role if you're on Discord, so just mention to any one of my staff who you are in there, and we'll make sure they get you hooked up on that. But thank you for the support, and thank you for being on the stream. So the other thing is, for database design, sometimes you need a combination. It's not uncommon to have a rigid database, which is the authority of your data, and then to have a schemaless mirror of that database to make it more efficient to pull data out of it. Because when you're using relational databases like MySQL or Postgres, sometimes it's hard to manipulate that data once it grows beyond a certain point. Once you hit millions of rows, it's hard to crunch the numbers. It's not a good tool for that. But if you can mirror that data out to something like a Mongo or Elasticsearch or Solr or Hadoop or Cassandra or something like that, then you can perform operations on that data a lot easier than you could in a relational database. But here again, when you combine a bunch of these tools together, you start, it just gets more complex. You got to manage more things. So Fox, thanks a lot for the 2. I appreciate that. Thank you. And then the last thing is just we're gonna get done here in just about 3 minutes, so bear with me. Is this idea of failover, disaster recovery, and backups. And see, there's so many challenges to scaling up. And the whole purpose of this is keep your services up when your hardware fails, restoring data if hardware fails, and restoring data due to loss from malice. And I throw that in there because as your application grows and your organization grows, you are at a higher risk of hackers. You're at a higher risk of, like disgruntled employees, insider jobs, things like that. So you have these problems as well. The implication is that if you're doing more traffic, you probably also have, excuse me, you probably also have more people. And more people means, you're not just scaling your infrastructure, you're also scaling your workforce. And that has its own challenges, which we're not really going to discuss here. But, the challenges with failover, disaster, and backups is that you're dealing with insane amounts of data, and it's never going to be quick. There's no silver bullet way to just make out a copy of a petabyte worth of data in a couple seconds. You can't do that. So you got to find other ways. And then oftentimes, the bigger your business gets, downtime equals loss of dollars, and this is a problem. So you have several options for dealing with this. The first is you want to maintain hot spares of application servers across regions. And the across regions is an important thing because if you put all your eggs in one basket, or more specifically, if you put all your servers in one data center, what happens if something happens to that one data center? You lose everything. But if you create hot spares in separate regions and shots, if you create snapshots in separate regions and you create replicated databases across regions, then you're much more tolerant to problems because you're able to get things back online quick, because it's unlikely that 2 different regions would simultaneously have problems causing a complete loss of your infrastructure. That's not a typical thing that would happen. But here again, I guess if you're a $500 billion business, maybe you don't want to bet on that. Maybe you need 3 regions. Maybe you need something overseas as well. So, and as far as backups goes, the common way to do backups is to do full backups as little as your company can tolerate, and then do differential backups of various things. Of course, backup application servers are easy because they really never change, or at least they shouldn't. And if they do, then you're usually like pushing the change out to all the places anyways. So you typically just keep one copy of your application server. That way you can create additional servers if you need to increase capacity, or if something happens, you can restore it from that particular snapshot. The problem comes with storage, and fortunately with storage is remember we talked about, making the data available to global users easier. Well, the one good thing about making the data available to global users is that you're duplicating the data. And by duplicating the data, you're in effect creating a backup anyways. So that's a good thing. Officially, JK, thank you. Really enjoyed the stream and the last. Well, thank you for being here. I appreciate the support. I'm glad I could convey some important knowledge. So it's kind of interesting to see that, by solving one problem, you technically solve a second problem. But if that's not the case, a common way to do databases is to replicate a database across regions and then take your backup from that database. The problem with backup databases is that if they're constantly changing, how do you get a consistent backup of a database? Because imagine if you start a backup and then by the time it makes it to the end of the backup, stuff has changed. Well, that's a problem. So typically what you do is you would create a replica database elsewhere, which would be populated from a main database. And then when it comes time to take a backup, you convert that replica into read-only. That way it can take on no more writes, do your differential backup, and then take it off read-only and get it catched up from its main database. Marcus, thanks a lot for the 20. I really appreciate that. Appreciate your work, EM. Thank you. Thank you for being for the stream. Hopefully I was able to convey some knowledge here. So we're at the end of the content. I want to just make sure I handled all the questions before we get going. So if you have, we'll do about 5 minutes of Q&A and then we will wrap things up. So if you didn't get your question answered, please put it in the chat now. Is there any plans to do the hashy stack? I'm not actually sure what that is. I'm sorry. All right, staging it. See. GridFS, Mongo files. Yeah. Well, so, okay, so Fox says, storing files locally, what do you think of Mongo files, GridFS, compared to plain file system storage regarding ease of scalability? So obviously, you know, those solutions were created to solve that problem. You know, people don't want to use normal files, and so they did create GridFS, Mongo files to do that. I think it's a good option because it just has a lot of management built into it. And it's just an improvement upon files. But I suppose at the end of the day, you know, everything really is a file at the end of the day. It's just how are you managing those files? And when we talk about file systems in general, we're speaking about just files kind of on the machine. But you know, there's a lot of improvements that are made that use files as the, you know, that are underpinned by traditional files. They're just managed in a certain way to where it's highly efficient. And we see this a lot, like a database, perfect example. Perfect example of that. I mean, all a database is a bunch of files. It's done in such a way where it has just really efficient operations that can be performed on it. So I see Mongo files and GridFS as kind of the same sort of thing. I think it's fine. API versus GraphQL for mobile app project. I think here again, I think it depends on your use case. You know, GraphQL is kind of a new, like a specific standard, but and when we say API, I assume you mean like REST API. I think it's just based on use case. I don't have a specific answer without knowing the exact like specifics of the mobile app or what you plan on doing, as well as the load and the type of stuff that it needs to access. So I think just pick the one that makes most sense for your use case. Oh, Daniel Thurston, thanks. Data retention. How do you handle customers wanting to keep files indefinitely? Well, the simple answer is you charge them for that, and then you just buy more storage. The good thing about data retention is that not all, I'm actually glad you brought this up, because there's usually different storage classes. You have a storage class that's supposed to be highly available, but then you have a storage class that's, you know, reduced availability, but higher durability. And the trade-off is the ping to retrieve that data is higher, but the cost to store it is lower, and it's often more durable. And then you have just archive storage, which is not designed to ever be accessed, but is extremely cheap. We're talking fractions of 1 penny per gigabyte. You know, you can store a terabyte worth of data for $5, for instance. And that's something that's interesting. So that's cold storage, exactly. Cold storage is this idea that it's data that you just put there, but you never actually need. And the cost of storage, you don't really need cold storage. You can get, you know, reduced availability storage for maybe double the price. So $10 instead of $5. And that often solves the same problem. But here again, you know, the colder the storage, the more expensive it typically is to access the data. So you got to take that into account as well, because they hit you with retrieval fees. Chris said, hi from Greece. You are great. Keep going. Thank you, Chris. I appreciate that. Thanks for coming to the stream. Okay, I think, oh, don't forget about advent of code storing soon. So yes, thank you for that. So the last announcement before we finish up is Advent of Code is every day there's going to be a new challenge for the month of December. So be on the lookout. Bratwurst usually heads that up. He'll be posting an announcement here shortly, probably in the next few days, which will give you the link for Advent of Code, and we'll all participate in that. I'll be participating as well. And then maybe I will send some free stuff to the winner, some stickers or Engineer Man stuff. So if you're not on Discord, definitely get on there. That's where it will be carried out, and then it'll post the, when people make solutions and whatnot. So if you want to get in on Advent of Code, it was a real good time last year. We had quite a few people take part in it. Instructions unclear. Yep, instructions unclear. Data got lost to Titus Deer. That's how it goes sometimes. So yeah, Advent of Code, really good time. So come and join us on the Discord server for that. So that's it for the stream. Next stream will be in 2 weeks from now, and it's going to be we're at our last two, and that's going to be it for season 2. Now, just to let everybody know, after season 2 concludes, I'm going to take a brief break, like I did last time, probably a couple months, and then in that time, we're going to come up with the next 10 or 11 live streams, which will be season 3. And that's how we're going to do it from now on. We'll create all the topics up front, and people can put their input in. Last time we created a channel on Discord to let people discuss what would be good, topics for the stream, and then I'll just carry them out in that same way. So it'll be nice. You'll know what's coming. It'll be already scheduled. I'll be able to produce good content because I'll already know what I'm doing it on, and it'll be great. So second to last stream will be on making the most of external tools. And this whole stream is, the whole purpose of that stream is just because there's so much technology out there, and sometimes people make bad use of this stuff, but there's a lot of things you can do to make good use of the tools, pick the right tools, make adaptations of tools, and various other things. So I think that stream will be about as informative as this one. So I hope everybody will attend that. I think that will be a good one. I think that's it. I've got all the questions. Thank you so much to everybody that attended the stream. It wasn't that big of a stream, and that's okay. I knew it wasn't going to be, because this is kind of a niche topic. But if you want to be a well-rounded engineer and you want to understand some of the challenges, that you'll eventually face at some point in your career, then this is a good stream. But sometimes people they don't need this, so I understand why it wasn't a massive stream. But that's not going to stop me. I'm not looking for the maximum amount of views or users. I'm looking for the maximum amount of knowledge transfer. So I hope people learned a lot today in this stream. So other than that, thanks to all the supporters. Please come to Discord, check out Advent of Code, and I'll see you 2 weeks from now for the second to last stream. Send me your projects if you haven't. If you want any stickers, the link's in the description. And then other than that, I hope everybody has a fantastic rest of your weekend. And I hope everybody had a fantastic Thanksgiving. Hope to see you on the Discord and future streams. Take care.